Hello, I'm Joe. This is Sierra Specialty Auto. Welcome back to the shop. A couple of months ago I did a video on a brake job on a Clark forklift. I mentioned during that video that I was resealing the transmission and the engine, and I've received several comments and messages, emails, asking me to be sure to show that process. Other people are apparently have these forklifts and are have a need to dig into them. So in today's video we're going to look at some of the work I did, and I have to apologize in advance for this. I did not get good camera angles on some of this. I forgot to turn the camera on in a couple of places where I really should have, but I believe I got enough video of enough of the job to make it worth putting up, and I hope it'll be enough to be of help to some of these people who have asked me to be sure to do this. Before I get into that, I want to recommend a fellow YouTuber. This is Chris McDonald at Just One Guy Metalworks. He's in Saskatchewan, Canada. He's got an Atlas lathe, and he does neat stuff with that. He's got a shop-built milling attachment that he uses extensively, and he does fun stuff like building reversible power feeds for it, like designing and building automatic center punches, quite a bit of fascinating stuff, and goes about it in an interesting and enjoyable manner. So I will put a link to Chris's YouTube channel down in the comments. Be sure to go check him out. He's great fun. I got his sticker over here on the big board. Let's say it's next to O-rings and more. And that's another link I'll put in the description. If you need O-rings, either Buna-N or EPDM or certain other materials, they're a great mail order outfit or internet outfit to deal with. Very reasonable prices, and they do not consider shipping to be a profit center. Up to $25 worth, I think, of product shipped for $4.95 here in the U.S., and over $25 is free. So if you need O-rings in small quantities, generally packs of 5 or 10, the minimum, check out oringsandmore.com. All right, let's go ahead and get started on this resealing job on this Clark transmission. I have the torque converter housing and all of the internal parts clean, ready for assembly. I will be installing the seals in these locations, and I will be installing the stator support over the main shaft. I will not be installing the pump cover at the moment because I'm pretty sure I need to be able to get to the ends of the clutch shafts as they come through these openings to align them, because the bearing at the other end does not hold them rigidly in line. I'll need to feed them into these openings. So that part of the assembly will wait until after the converter, the torque converter housing, is bolted to the transmission. But I will go ahead and set these seals. All three of these seals go flush with the inner surface. These two inside the pump cover go with the spring facing us, or facing the inside of the pump chamber, and the one at the bottom seals in the other direction, because this is open to the atmosphere when everything's put together. So the spring on this one needs to face the opposite direction. I think I'm ready to drop this torque converter housing down in and bolt it to the transmission. I've got new seal on here. This is an O-ring that goes all the way around, and this is a square section O-ring that goes all the way around on this surface. I'll put a close-up here. This O-ring right here, I've got bedded in some Vaseline to keep it in place. This was the source of one of my major leaks. The O-ring that came out of here was rock hard and measured less than the depth of the recess that it fits into. So there was a continuous stream, weeping of fluid out of that O-ring and across this depression and down into the torque converter housing and out the bottom, and it was a mess. This is a good place to talk about more of these O-rings. There are 3 underneath the transmission control cover. Here's a picture of that. Measures about 6 by 8 inches. It's on top of the transmission. Here's an image from the parts book showing the location of the O-ring. Here's another image from the overhaul manual, again showing the location of the 3 O-rings. This picture is again from the repair manual. It shows 2 more O-rings on the oil pump cover. That's return oil to the pump and pressurized oil out of the pump. And another image from the parts book showing the oil pump cover. Here's a picture of the 3 O-rings I took out of the control cover. They were all leaking internally, and this thing, the forward and reverse gears were very mushy, very weak on this forklift because of the condition of those O-rings. And the heck of it is that they were leaking internally, not externally. So it was more or less good fortune that I found those while I was rebuilding the inching valve, which is also in the control cover. Again, none of these 6 O-rings are mentioned specifically anywhere in the overhaul manual. A couple of hydraulic hoses over here I need to be sneaking by as I come in. At this point, I've got a couple of long 7/16 bolts. I'm going to try to get started in the appropriate place to serve as a guide. When this thing goes in, it has to go dead center. I've got that hanging on the 7/16 bolts. I'm going to try to get in there with it now. Get this hoist out of the way. I'm looking at my shafts down here. I have to make sure those bearings come into their bores. I've got to watch this gap, make sure it stays uniform all the way around as it goes in. Looks like my shafts are coming through properly down here. I've got some slightly longer bolts. I'm going to try getting them started. See if I can pull it in with no more tension than I can apply with a speed handle. I hope these are an appropriate length. That one lines up really nicely. I have a new O-ring installed on the pinion shaft at the bottom of the torque converter housing. There. I have my pump cover and the back side of the pump cover gasket coated with a thin layer of Permatex number 3. I've got new O-rings in the pump port O-ring recesses. They're held in with some Vaseline, the old transmission rebuilder's trick, that Vaseline will dissolve in the transmission fluid. And now I am ready to put the pump cover in. Oh, I also have the stator, the torque converter drive gear is in position on the input shaft. Let's get onto that right there. So now I'm ready to climb in there and install the pump cover. This is one of the rare cases when I do not replace the lock washers. These are a special thick lock washer with a reduced diameter captive. They won't come off. I don't see any particular point in changing those. Pro tip: install the regulator valve into this threaded port before you install the pump drive cover, because you can't put it in after you install the cover. You'll have to take the cover off and install the valve and then put the cover back on. Ask me how I know this. And there's one long bolt in one tall position on the pump cover. All the rest are the same length. In a place like this, I like a speed handle even better than an electric ratchet. Now I'm going to snug them just enough to get the tension out of the lock washers, but not much more. And let that set for about 10 minutes, and then come back and go around the pattern to torque. As you can see, we're looking at the bearing on the differential, the ring gear carrier, and it is approximately in correct position. If we take the other bearing carrier out while this one is out, that whole thing will drop. Here's the bearing carrier, clean and lubricated. I think that O-ring is resisting. I'm going to put just the nuts for the moment, a pair of nuts. And draw the carrier into place with a speed handle. That drew in smoothly and evenly. That felt really good. Now we'll put the rest of the hardware on and tighten that to spec. I've got my rear and front filler blocks coated with Permatex number 3 as per the manual, and also the inside surface of the rubber seal that goes over this. And I'm going to put those on, bolt the hood down, or the pan down with 4 bolts, and let this set up for a couple of hours, and hopefully they'll take their firm position and stay there while I'm doing the RTV. The new gasket kit comes with the seals for the front and the rear, and a tube of RTV for the gasket itself. No paper in the new kit. I'm a little bit concerned with this front filler block. This has been over tightened and deformed to the point where it's a little bit wavy, and I'm hoping that this will help keep the seals seated in those waves. I think maybe it will. I've got all the threads have been chased in the block, and the threads have been run through a die nut on all the fasteners, so we should not have any issues there. Want to draw these down fairly uniformly. No need to tighten these right now, just run them up snug. Now I'll come back in a couple of hours and see if that worked. We'll take the pan off, make sure the rubber strips are remaining seated, and lay on a bead of RTV on the inside of these holes. None of these are through holes. They're all blind that stop in the cast iron, so we don't have to seal the threads of the bolts. I think that was successful. I'm going to do a tiny bit of cleanup of the Permatex around the ends of the rubber strips. Then I'm going to lay a bead of RTV around for the pan gasket, and I think I'm going to put a very thin wipe of RTV on the mating surface so that it is, let's say, primed. Because I'm reluctant just to depend on a bead. I will let the bead skim over for about 15 minutes in accordance with the instructions, and then I think that'll work. That ought to do it for the thin bead, for the bead on the block. Now I'm going to do a thin wipe on the edges of the pan. It's been about 15 minutes since I laid the beads on here, and probably 10 minutes since I finished wiping a thin layer onto the pan, including these surfaces that will mate here. This rubber has ribs that I think will probably seal fully well by themselves, but I also put a thin wipe over them. So let's set the pan back on, bolt it up for the last time. The pan is sitting, probably a little bit less than 1/8 of an inch. Well, maybe right a little bit more than 1/8 of an inch off of the block surface. So I think when this pulls down, it'll have very good contact. So I'm going to run these up just until they start to wind on the, just until they make good contact, and then let it cure for another 15 or 20 minutes, and then go through and do a final torque. Now I'll go around and torque to 20 foot-pounds. The book specification for pan bolts is 12 to 16 pounds, but that is assuming a gasket. We do not have a gasket, we're metal to metal, so I'm going to go to a more appropriate spec for a 5/16 fastener, 20 pounds. I will start in the middle and work out on each side. Probably overkill for a pan gasket, but I'm going to do a graduated torque. I'll go to 10, and then come back and go to 20. That completes the pan gasket installation. That also completes the sealing of the engine. I've got a couple of more little detail things to take care of, and then we'll be ready to put the engine back into the forklift and fire it up and see how well I did making this thing continent again. That's it for the Clark transmission. I'm happy to report it's been probably a couple of months since I finished that job, and that tractor is dry. That forklift is dry. There are no engine leaks, no transmission leaks, no differential leaks. Whereas before I had to chase this thing around with towels and rags. Every time I would stop, it would leave two or three puddles of various liquids, and now it's bone dry. So the job worked out very well, and I hope this is of enough benefit to enough people to be worth the trouble. Thanks for watching. I appreciate it.